So every time we're thinking about publicly available operations present in our classes, they primarily constitute the interface, a public interface to this object. So basically we would like to view our classes based on their public interfaces. And anything implementation specific, most of the time, the data attributes should all be hidden and made private as opposed to public. Class users don't need to know anything about class implementation to use objects effectively. What it means is that essentially if the list of attributes changes and internal implementation of operations has to be updated, if the rest of the system is using only these public operations, it will not be affected by our changes. So that gives us some space for and flexibility for making updates, further development and changes in the internal implementation of each class that we're trying to originally model, and then of course we have to write code for it. Changes in implementation should not require changes in user code. So that means that the user code, basically this is the user code that is located elsewhere in the system outside of a specific class where we're trying to make updates and changes. The role of constructors. First of all, what is constructor? Constructor is an operation, a function in C++ or a method in Java which allows to initialize an object from the very first movement from its creation, to initialize it to a known state. In other words, instead of accepting some random values in memory where the object was originally placed, we would like to populate that memory with known values that we would like to be able to control and understand from the beginning of the object's life cycle. In programming environments such as Java and C#, the objects are destroyed automatically as soon as they're no longer being connected to any other parts of the system. So as long as there are no other references in the system, the objects can be garbage collected and removed from memory. In C++, however, there is also the opposite part of the constructor. There's an operation called a destructor, and destructor is responsible for freeing up any dynamic memory resources or any other resources associated with memory occupied by the object. So there's an additional thing to this in C++ programming environment. When the object design and its code is fully written, it becomes a well-understood component in the system. So it becomes reasonably a unit of maintenance, a well-understood part that should be well documented, and of course it also can be tested independently. So relatively speaking, it's a quite modular component of our system, and therefore there's this question, could such a unit as fully defined class be reused somewhere else in our future designs and our future classes? Well, the answer is basically yes and no. We can try to claim that such objects could be highly reusable elsewhere, could be quite overstated. So concepts such as polymorphic operations and encapsulation of internal data are actually much more important benefits from having well-defined classes rather than the expectation that a class can be instantly reused somewhere else. And the software that we're trying to design is not really primarily focusing on reuse, but rather the correct behavior, correct functionality, good performance, and other constraints, trade-offs many other things. So object reuse is a great promise and great concept, but it's not a primary focus of the original design. Oftentimes there is a potential reuse in the future, but at the same time expect that if you just copy and paste your classes into a future system, of course you have to review their internal structure and design, and expect the need to adapt them by making appropriate changes. We need to be consistent in providing names to our classes, attributes, and operations. And altogether, the way we express naming our data types, our variables, our operations comprises the idea of our style. And of course, we could use all sorts of combinations of uppercase and lowercase. For example, all uppercase typically is used with constant values or macros in C and C++. Lowercase is a typical approach in C++ to use to name local variables and member functions of classes. Mixed case is used typically to name classes and structures. Title case could be used for naming global variables. And camel case is a typical approach to name data attributes and methods in Java and C#. So given these different styles, we need to be aware to use them consistently, and using abbreviations can be very difficult for readability of our code. Oftentimes commercial systems have programming guides that basically say that the use of them is completely banned, should not be applied. So abbreviations is really not a good approach. Acronyms is a different story, but abbreviations, like basically shortening the words to a certain level, could be very inconsistent. It's very hard to maintain the same level of consistency, and not everybody perceives such abbreviations in the same way. So just try to stay away from it. It's a better idea to use complete words in naming. Of course, code alignment, white space is another part of a style, and that is something to be consistent with. Each variable, each object is declared in its own scope. So for example, here we have a function swap, a C-style function that takes a couple of pointers to integers and swaps their values internally. Upon return from swap, what happens is that the two integers in our case are swapped. Their values are swapped between each other. So swap requires a creation of a temporary variable, and of course this temporary variable is used only for the reasons of swapping two integer numbers. So declaring such variable outside of the function, for example in a global scope or at some class level, somewhere else rather, would be not a good idea. You really need to pay attention that the data abstraction and hiding closely relates to the scopes of variables, and you want to keep the scopes of your variables as localized as possible. In other words, declare your variables in the scope where they really are being used. A few guidelines regarding maintainability of our software. A few words about maintainability of software. We'd like to design our systems with future maintenance in mind, expecting that future changes, of course, will be needed, adjustments, bug fixes, overall improvements new ideas, and so forth. So all of this is regarding maintainability is very important. So how can we improve maintainability? Perhaps we need to comment every non-trivial part of our code. That is important to improve readability of the code, as opposed to just keep guessing what was the original idea about specific part. So like I said, every non-trivial piece of code deserves a comment. And comments are ways to document our code directly in the source. We need to be consistent with the style, which includes naming of everything, space indentation, and overall use of programming language facilities also needs to be consistent. We should minimize dependencies and reduce the number of static variables. The static variables could be very dangerous in multi-threading environments, which are typical for modern software. So basically, static variable, unless it's a constant, may indicate a potential design flaw in the system. And of course, as we mentioned earlier, try to not to create too many unnecessary temporary variables, and keep them, or keep their scopes, as low as possible. Recall earlier that we mentioned that implementation model was just part of other types of design models. We talked about it earlier in our course. So overall, software development is a highly iterative process. It's incremental but also iterative, meaning that you're stopping where you are currently and you have to revisit earlier stages, earlier documentation, and your design. So each such stage is revisited repeatedly, and we need to be able to refine what we're doing. So pretending that you always start with a clean state is not a correct assumption. You have to be able to critically revisit every part and be able to be flexible and make changes as necessary. Also, pretending that one day there will be a final delivery of the system, which will be an ideal product and no longer will need any kind of maintenance or any type of redesign or improvements, is also a completely false assumption, and obviously you're thinking in the wrong direction. The design is really a series of incremental steps and iterations back to previous stages. And right here, when we say that we continue with some implementation, means that we're addressing those small incremental process steps that we can attempt after fully understanding what is our current state and where we stand with this system. Development stages include analysis, design, and implementation, but notice that in this bulleted list there are no numbers. It's not numbered. Basically, that means that these stages highly intersect and are highly iterative. So the design obviously is a creation of a structure of the system, so that we understand what classes we'd like to have in place. We understand what data attributes, what operations have to be present and where. At the same time, the analysis identifies the processes of these objects interacting between each other at runtime. So we're defining the scope of the problem, we're defining the processes, we're defining scenarios within each use case, and that helps us to understand the needs for specific classes. And of course, implementation is writing and testing the code. Now notice this is not just writing the code, but also testing it, because you don't want to write the entire system and only then start testing it. That would be also a wrong approach. So at all levels, whoever is involved in the process of developing the system should be interacting with each other and not be way too compartmentalized in their own departments. At the same time, it is very important to apply appropriate degree of formality, and formality primarily refers to the level of documentation that you need to have to support your system, to be able to advance it adequately. And that, of course, also refers to using correct comments and enough comments in your code to make it clean and readable. And so all of the stages that we're talking about need to be recognized and kept as separate stages and not mixed with each other. So this is our presentation for today and some UML examples for us to consider in terms of design guidelines and some rules for putting together a commercial software system.